All right. Hello, friends. Welcome to the classwork for 2.2. We're going to go ahead and get started. You can see that the exercises are going to be at page 84, 1, 11 through 19, 23, 31 through 35, 39, and 41 odd. And again, make sure in your homework that you are noting this section, exercises, with that page number and with the problem set clearly included. All right, let's go ahead and take a look at number 11. I'm going to be doing, for this video, 11, 13, 17, 23, 31, and 35. So number 11, it says, determine if each conditional is true. If false, give a counterexample. So number 11 reads, if the season is spring, then the month is March. So I could quickly just guess, so if spring, you don't have to necessarily write this, I'm just writing it, then March. So is that true? Where it is in fact spring, the hypothesis has to be true. To prove it false, then it has to be the month of March. Well, no, if you notice, each season takes on 3 different months. So spring is March, April, and May. So this would be false because it could be April or May. Either one would be a counterexample. But again, the hypothesis is still true. It is spring, but it's false because it doesn't have to be March. It could be April. So there's an example of a counterexample proving a conditional statement false. Okay, next I'm going to take a look at 13. 13 is simple. It says identify the hypothesis and the conclusion for each conditional statement. This is pretty straightforward, but I just didn't want it to be confusing for you. Number 13 says, if an animal is a tabby, then it is a cat. So the hypothesis would be the first part there that follows the if. So the hypothesis would be an animal is a tabby. Whoops, this is aminal. If an animal is a tabby, and the conclusion follows the then, I'm just abbreviating those, it is a cat. Yes. Alrighty, and so converse, you would switch those. Inverse, you would put not in front of each one, or contrapositive, you would do both, but we'll get to that eventually. So let's take a look at number 17. Number 17, write a conditional statement for each sentence. Sometimes these can be tricky. They're going to give you a sentence with information, and you have to think, okay, what part is the hypothesis? Which part is the conclusion? Which part follows the other? So 17 says, after 3 strikes, the batter is out. After 3 strikes, the batter is out. Well, what's the condition that has to be met? If the batter makes 3 strikes. If the batter, we'll say takes, for all you baseball fans out there, go Dodgers. So we don't want 3 strikes for them. Okay, if the batter takes 3 strikes, well, what happens? Then the batter is out. And so we have turned that sentence into a conditional statement where if one part is predicated on the other part, the being out is predicated on the hypothesis of the 3 strikes. Okay. If we said it the other way, if the batter is out, then the batter takes 3 strikes. That's not necessarily true because that's not based upon the 3 strikes. You don't. There's other ways to get out besides recording the 3 strikes. But if you take the 3 strikes, you're definitely out. Okay, so let's go try number 23 now. So in writing those, just read the sentence and see which way does it make the most sense. 23, this one we're going to write a converse, inverse, and contrapositive of each statement and evaluate if they're true. So this will be a little longer where we get to go through all 3 different versions of the conditional statement. So 23 says, if freezing rain is falling, then the air temperature is 32 degrees or less. So I'm just going to abbreviate what they give us to have it as a reference point. If, and you got to be careful about abbreviating, but it's all right. If freezing rain then I'm going to go try it this way. Well, no, Q. Then it is 32 degrees or less. Now, when you write this out, I think it'd be a good idea to write it out exactly. I'm just kind of going quickly for the demonstration, because you could get a little sloppy if you leave out some of the words. But the basic idea, if it's freezing rain coming from the sky, then the temperature of the air is 32 degrees or less. So that's our conditional statement, where the hypothesis is the freezing rain, and the conclusion is that the air temperature must be 32 degrees or less. And again, they've given you the hint that that's true, because at 32 degrees, that's when water begins to freeze. So let's go ahead and look at the converse, where we're going to switch. We're going to switch our P and our Q for our converse. So let's go ahead and say, okay, if it is 32 degrees or less, or the air temperature is 32 degrees Fahrenheit or less, then freezing rain is falling. Actually, I'm going to go ahead and then freezing rain, okay, for my shorthand here. Is that true? So if it's below 32 degrees, do you have freezing rain falling? Now, I can think of a counterexample. That's false. You could just say it's not raining. Just because it's cold, just because it's cold doesn't mean it has to be raining. So we would say, no, that is false. Let's try the inverse. Okay, and that's where we're going to go back to the original, but we're going to now negate it. So if not freezing rain, okay, try to have nicer penmanship than me at this point, then it is not, okay, to write not big, remind yourself, 32 degrees or less. Okay, so if it's not freezing rain, then it can't be below 32 degrees or less. Remember, that's going to be just like the converse. Converse and inverses go together for truth values. So that's false. No, it could just not be raining. It could be that there's nothing falling and there's no freezing rain, but it could still be colder than 32 degrees. So again, you can usually use the same counterexample for both the converse and the inverse when you do them. All right, so let's just do the contrapositive now. Whoops. All righty, contrapositive. That's where we're going to switch the conclusion and the hypothesis and negate both of them. So if not freezing rain, oh no, I'm sorry. Oh, I gotta say that. If not 32 degrees or less, then not freezing rain. Okay, and ask yourself if that's true. And again, shortcut, contrapositive. If the conditional is true, your contrapositive is going to be true. So that makes sense. If it's not freezing temperature, air temperature, then you're not going to get freezing rain. So that is the right color, stay consistent, true. All right, so there's an example again of going through all forms of a conditional statement, from the initial conditional statement, which fact check true. Then many times the conditional or the converse and the inverse will be the same, but opposite of the conditional. Not always. That's not always true. But what is true, your converse and inverse work together, while as your conditional and your contrapositive work together. Okay, so that was 23. Let's take a look at 31. And again, make sure you put in some time to get your inverse, converse, and contrapositive figured out. You don't want those vaguely floating around in your head and you can't. It's like supplement and complement. You want to know the difference between them. 31 is just an example of viewing the Venn diagram where it says all natural numbers are real numbers. Even if you don't know and remember what natural numbers and real numbers are, you can realize that the hypothesis goes in the middle. So that would be all natural numbers that goes in the center, and that falls within the larger category of real numbers. Natural numbers are numbers that go from 0 on up to infinity without fractions or decimals. So like 0, 1, 2, 3, 4, 5, 27, 47, 2000. And those all do fall within the category of real numbers. Get in Algebra 2, maybe in Algebra 1 you did it. We'll talk more about that. But notice whatever's in the middle, this is your P or your hypothesis. I want to change colors there. What's in the middle is your P or your hypothesis. What's out here is your Q or your conclusion. Okay. All right, and finally, let's take a look at 35. This is so fun. Not a single bit of math calculation to speak of. Some of you might enjoy that, hopefully. 35 is the opposite. They give you the Venn diagram, and you have to write the conditional statement. So we see the word Texans inside the circle of Americans. Remember, the inside is the if, the outside is the then. So if you are a Texan, or if a person is a Texan, then that whatever's on the outside, they must be within that broader category also. Then you are an American. And it doesn't really, just so you know, it doesn't say whether to find out if that's true or not. This one is, in fact, true. And so we're good. But there you go. You can take a Venn diagram. The middle point is your if. The outer point is your conclusion of that. Alrighty, I hope this is helpful. Hope you enjoy this lesson. And again, write neatly and reach out if you need any help, because I'd be happy to do what I can. All right.